This is the last day of our acquaintance. I will meet you later in somebody's office. I'll talk, but you won't listen to me. I know what your answer will be. I know you don't love me anymore. You used to hold my hand when the plane took off.
All right, so this is our last review and last class for the entire semester. And remember that your final exam is on Monday. It opens at 12:01 a.m. You'll have 24 hours to do it, minus 2 minutes. Same stuff as all the previous exams. No collaboration, and there will be no help hours during the finals week. But let's see. Hopefully this works. Okay, it was just paused. All right, so this is a final from many years ago here, from 2018. And you're going to be doing some data processing, again, searching and sorting. Pokemon is a game in which fictional animals fight each other, and there are types of attacks, right? There are Pokemon that are ice Pokemon, grass Pokemon, or fire Pokemon. And when type A attacks type B, then there can be a multiplier attached to it. So 0% effective, 50% effective, normal, 100% effective, and 200% effective, super effective. And this is all spelled out in the following grid here, right? So for example, when a normal Pokemon attacks I think that's a rock Pokemon, then it's 1/2 as effective. And when it attacks a ghost Pokemon, then it's not effective at all, okay? So here we're given data based on, well, here I'll show you what the data looks like. We're given a bunch of Pokemon here, right? 1 through 151. They're all identified by an ID, a name, and then their type. And this is a CSV file. So we're going to have to process this file to load up all the Pokemon, because given 2 Pokemon, say Jinx and Flareon here, then you have to output something that looks like this. Jinx, which is of an ice type Pokemon, attacks Flareon, which is a type fire Pokemon, and then you would look up in this DAT file here, right? Let's see, what was that? Ice to fire. Find ice to fire. It's half as effective, right? And so there are 2 files to deal with here, just like in the football example that we did on Wednesday. Okay, there we go. We're working. All right, so we also gave some starter code here, very similar to what we gave for the one on Wednesday. We've got a deep copy string function. We've got a split function that splits it along some sort of delimiter. We've got a chomp function that is used internally by this split function. Free string array to free whatever you get out of that split function. And then to add any other functions that you might see fit to add. Right? So the way that we're going to have to do this is we're going to have to take that first name and that second name, and we're going to have to process the first file here to find out what type they are. Right? So what was that? Jinx? There we go. They're an ice type. Right? And then we would look up Flare. There it goes. Flareon, and then their fire type. Right? And then we would have to process this file to find that one particular line that gives us the final answer here of 0.5, half as effective. Note here that this is not a CSV file. This is a space delimited file. All right, so what I want to do is I want to use searching and sorting. Given a name, I want to be able to look up their type. That means that I'm going to have to store all these Pokemon. So let's come over here to the utilities class, not class, but the utilities file over here, and let's define an object. Let's define a structure that represents a Pokemon. Type def Shift-F. There we go, struct. And then I'm going to call it Pokemon. Right? And it's going to hold those 3 elements. It's going to hold its ID, which is an integer. Right? It's going to hold its name, which is a char star name. Now, what we saw a lot on the airports is that people hard-coded those things. We didn't take off for it, but that's, there's no Pokemon with a name more than 100 or 99 characters. And so you might be safe. But there are places where, the names are very long, right? So do you then just make it super big so that you can accommodate all those things? Well, now you're wasting about 10 kilobytes. And if you're in an embedded system or if you're in a memory critical system, that is not an option, right? So I'm going to go ahead and use the proper way that we've been covering it with a pointer to it. After all, we gave you a deep copy string function here. We're going to use it, right? What else is in that file? Oh, yeah, the type. Right? And I'm just going to represent that as a string, okay? Now let's come over here and load up that file, right? And process all those Pokemon, because eventually we're gonna have to search through them for the ones that are given as command line arguments. So 1, process the Pokemon.csv file and load up all Pokemon. Right? Now normally I would want to go through this and count up the number of Pokemon, and then because it might be different, right? I think that this is old. This is an older Pokemon. There are more than 151 Pokemon now. Right? So like they added 152, right? But for this one, it's okay to just hard code that there are 151 Pokemon, right? So let me go ahead and create an array to hold all those. Pokemon is equal to Pokemon call to malloc, right? Actually, what you could do here, if you really wanted to, since you're going to hard code it anyway, you could do 151, right? And you could get away with that. But this is a review, so let's do it in a proper way. As equal to Pokemon star malloc, call to malloc. How many of them do you want? 151. In fact, 151, I'm going to probably be using that everywhere. So let's go ahead and say num Pokemon equals 151. And put that into, because I'm probably going to go over a for loop. I'm probably going to use qsort. Probably going to use bsearch, right? So num Pokemon times size of Pokemon. So not too common, but something that we also saw was something like this. Why would I add one? In this situation, I wouldn't. But we saw this because people were confusing strings, where you always add one for the null terminating character, and other things that were not strings, where you don't add one because there's no null terminating character. Okay. All right, there's my Pokemon. Now let's open up the file. Pokemon file, I'll call it that. Fopen, and I'm going to open up the Pokemon.csv file in the current working directory for the purposes of reading it. Right? File input. Now here I've already hard-coded this, so let's go ahead and just use that. For int I equals 0, I is less than num Pokemon, I plus, num Pokemon, I plus plus. Right? I'm going to read line by line, and there is no first line here. The first line is not metadata, it's not a count. That is the actual first Pokemon. Right? So I will read that line. That means that I need a buffer. So char buffer 1000 is big enough. Right? Forgets into buffer at most 1000 minus 1 characters, reading in from the Pokemon file. Okay. Now I could check to see if that returned null because it got to the end of the file, but I know that the file is 151 lines, at least 151 lines. So I'm just going to go ahead and hard code it like this for now. Right? Now with that buffer, I'm going to use one of those functions that we were given, that split function, split, and that will give me char star star tokens, split. We're going to split the buffer, the line, and we're going to split it along commas. And I need to know how many tokens there are. So let's go ahead and go with num tokens. And just like last time, I'm going to have to declare that first of all, but I'm going to pass it as a return by, or as a pass by reference. because it's going to tell me that there are 3 tokens. If there are not 3 tokens, then there is something wrong with that file at that line. Printf, something went wrong. Right? %s, and I'll print out the buffer here. Right? Okay. And that'll kind of tell us where it went wrong. Here I can exit. Now we still see folks using exit in, say, inside of another function here. If, for example, you gave me null, then I'm going to go ahead and print something. Printf cannot be null, and the line, and then exit on them, right? So that is not acceptable. Those are the 2 things that you do not do when error handling. You should be returning an error code instead. Okay? So why is it different over here in the main? Well, there's no recovering from bad input files. Right? There's no return. I'm already in the main. What do I return an error code to? The operating system. At which point I am returning an error code of 1 to the operating system. Okay? That's the only time that you would do something like that in the main. I've got my tokens. Let's create that Pokemon. Pokemon sub I dot ID is equal to that first token, token sub 0. But that first token is a string. And the ID, what was it again? Was an integer. A to I of token sub 1. Pokemon of I dot name is equal to token sub 1. Does that look right? What kind of a copy is that? Yeah, well, what kind of a copy am I doing right here, though? Remember, there are shallow copies and deep copies. This is a shallow copy. I'm making that pointer point to that thing over there, right? And that's not how it works, right? What I would have to do is I would have to allocate memory for this. So I'm going to have to make a call to malloc and then call strcpy. But remember, we already gave you that deep string copy right there. So let's use it. There we go. Deep string copy of tokens of 1. Likewise, the same thing for type. Right. Once again, why am I using the dot operator here? It's an index and it's a regular old structure. Right? Oops. And don't copy pasta without making sure that you change the sauce. Right? There you go. All right. I like that. I just invented that. That's great. Right? Copy pasting leads to spaghetti code. And if you're going to copy pasta, make sure that you change the sauce. Right? From the source, you need to change to what you copied to. Right? All right. I'm going to use that from now on. Cool. All right. So I've got all my Pokemon. Let's go ahead and make sure that we actually did it correctly. Printf, or not printf, but for int I equals 0, I is less than num Pokemon, I++. Printf. Let's make sure that the ith Pokemon there has their... We don't care about the ID. We only care about the name and the type and the line. So Pokemon sub I dot name and Pokemon sub I dot type. There we go. So GCC utils.c and Pokemon.c. There we go. Should have done it with the warning flag here. I don't know. Well, here, let's use the handout here. Jinx and Flaren. Oops. Cancel that. There we go. Paste. There we go. All right. Anybody know anything about Pokemon? Hitmonlee, is it fighting? Yeah. Is Dodrio, is it normal? Okay. Jigglypuff is normal? Okay, so I buy that it's correct. This is good debugging code, ad hoc debugging code. It does not belong in your final submission. Right? If you comment it out, fine, because you want to come back to it and use it again for some reason, fine, but it doesn't belong in any form in your final submission, right? Okay, so I'll leave it there in case we need it. Okay. All right, so I now need to find the 2 Pokemon that you were actually given, Jinx and Flaren. So I could go through all 151 and compare, is that the name I'm looking for? No. Is that the name I'm looking for? No. Is that the name I'm looking for? No. Or I could use what we've learned over the last 2 weeks and let the standard library do it for me. Right? In particular, what I want to do is I want to create a comparator, right? Pokemon, CMP Pokemon by what name is what we want. Right? Const void star A and const void star B. Right? To do add documentation later. Right? All right. So there's my comparator. Now the first step would of course be to force them to become to const Pokemon star X, right? Const Pokemon star of A, and const Pokemon star Y of B. There we go, Y. And now I can use strcmp, return strcmp of X's. Why am I using the arrow now? Because it's a pointer now. Their name and then Y's name. Doesn't matter ascending or descending because we're just going to use this in B search as well. But once I've got that comparator, I can use it over here. I can Q sort all my Pokemon, not by their Pokédex index number 1, 2, 3, 4, 5, but by their name. There are num Pokemon, and each one is of size of Pokemon. In fact, let me restore this now and make sure that our comparator is working. A.out. There we go. Oops. Same as before, Jinx and Flareon. Zubat is now down at the bottom. And who should be at the top? Does anybody know? Are there any Pokemon with A? Avron? Oh, Abra. Okay. Avron? I don't see Abra. Oh, Abra. Okay. Oh, Abra. All right. There you go. Is that in lexicographic order? Yes. Right. So once again, I'm going to go ahead and get rid of that. I was just doing a spot checking, making sure that it was correct. Now let's find the two input Pokemon. Okay. I want to find the one with argv sub 1, find the attacking Pokemon is going to be the one with name equal to argv sub 1. So let's find them. Pokemon, right, attacking, is equal to, what can I use now? B search, which is going to return a void pointer that I cast to a Pokemon so that pointer so that I can deal with it, right? So B search. Uh-oh, what's my key? Is it argv sub 1? Well, let's come back to that. Yeah, you got to compare apples to apples, right? What is my key here? If I'm searching an array, a collection of Pokemon, then my key also has to be a Pokemon. Pokemon attacking, I'll call it key. Right? And I also want, what else? A Pokemon defending. Is that what you would call it? Defending key, right? Now, that attacking key needs to have their name set to argv sub 1. Okay? So attacking key dot name is equal to argv sub 1. That might work, might not. Right? Probably will work in this case, but that's not the proper way of doing it. What was it called? Deep copy? Do that instead. There we go. Right. Likewise, for defending key, I will do it as 2. Right? The third command line argument. And then the actual defending Pokemon. Defending. The first key here is going to be the attacking key. The second key is going to be the defending key. Careful. That's a regular old variable. It expects a pointer. So what do I have to do in front of it? Ampersand and ampersand. Once again, let's make sure that it's correct by simply just reusing this printf function. Right? And it'll be attacking. Now, it's not in the array anymore. I mean, it is, but it's a pointer now, so I'm going to change this into a arrow instead. Right? And then defending Pokemon, I guess let's do attacking and then make sure that the defending is also correct. right? Attacking, defending, defending, and defending. Right? Oops. Defending key? It's right there. Pokemon. Uh-oh, there's a... Oh, I probably forgot a semicolon somewhere. There we go. Semicolon, semicolon. Anytime you see this and you think, wait a second, no, that code is correct, right? It's because there was an expected semicolon before that line, right? There was no error on line 41. The error was on line 40 right before it, and I had forgotten a semicolon right there. Okay. All right, now does that compile? Always be compiling with the wall flag and the G flag in case you want to fire up GDB. Let's run it again and make sure that we got Jinx and Flare on. Are they ice and fire? Oh, the handout said they were. Ice and fire. Okay. All right, so we're halfway there. Once again, get rid of that debugging code right there. All I have to do now is open up this other file and find the combination of their types. Okay. There are a couple of ways of doing this. We could do it the quick and dirty way. We could do it the over-engineered way. The over-engineered way that I'm thinking about would be look something like this. Do another type def struct, right? And then it's going to be the attacking type, and then defending type, right? And then the multiplier, so that would be a double, right? Multiplier, right? You could do something like that and then load up each line is going to be, what would we even call this? Pokemon combo or something like that, right? We could do something like that, and if you want to go the full 9, we can, right? In fact, we have plenty of time if we want to do it that way. Otherwise, the other way that I was thinking of, well, we already have their type, right? I have an attacking type, and if I were to add in a space and use the defending type, then all I have to do is go through that file and find the particular line that starts with that combination. Right? For example, once again, ice and fire, all I have to do is find that ice space fire, and then I know that that's right there. Do we want to do it? That's the quick and dirty way. Do we want to do it the quick and dirty way, or do we want to do it the clean way?
Is there a benefit to doing it the fancy way?
Just more review, but it's basically the same thing we've covered all week. File I/O, creating a comparator, using QSort, using bsearch. Quick way? All right. All right. For that, I want a temporary string. Right? So let's go ahead and create a temporary string, char temp, and I'll just make it large there. Right? And into temp, I am going to copy strcpy. I don't have to use malloc because it's already allocated up here. It's static. I'm going to strcpy into temp, attacking type. Right, there we go. And then strcat into temp a space, right? And then strcat into temp defending type. And then I'm also going to want one more space because after that is the actual number that I want.
Does cat automatically do the alternator?
Yes, in this case it does. But I don't even like that solution because that's 4 lines. I can do it in 1 line. Sprintf. Remember that guy? Sprintf. Right? You can use %s, and a space. Right? And then that takes it down to 1 line. Attacking type, defending type. There we go. And I can get rid of these 4 lines. And that'll take care of all the formatting for me. Now there is printf would print that to the standard output. Sprintf needs to know where you're printing to, and that's going to be to temp. Okay. At this point, I'm going to probably rename this. What is it called? Line starts with. I don't know. What do you want? Whatever you want to call it, right? It'd probably be line. What is it? Prepend line, prepend, or something like that. Line start. There. That's good. Remember, there are only 2 difficult things. One of them is naming things. Right? I want to find the line in that file now. Oh, by the way, what did I not do? with my file up here?
If no,
I didn't do any error checking, but more importantly, I didn't close it. There we go. Now this next file, I'm definitely going to close it. Right? File, what would I call it? Type file, right? Multiplier file, something like that. Is going to be fopen, and that's going to be Pokemon types.dat, and it's for the purposes of reading. Don't forget to close it. That's what I forgot to do, and so I'm going to immediately go down several lines. Remember to do that so that I don't forget it this time. Okay. There are 324 lines here. If I gave you 2 fake Pokemon, right? I don't know. Ryan Gosling. Right, there we go. I was watching Drive earlier today, and also wasn't he supposed to be? No, it's not Ryan Gosling. Who is it? The guy who's the voice of the Pokemon. What? It's Deadpool. What? Ryan Reynolds. There we go. Deadpool. I'll just put there. That's definitely not a. Thank you, Detective Pikachu. I saw that with my kids. I thought I knew what I was talking about there. Anyway, Deadpool, right? Segmentation fault. We would not give you bad data on an exam unless we explicitly said this is a possibility that there might be missing data. You need to report that, right? So we're not going to have this situation here. And I don't really need to process every single line. Once I get to that one line, fire, ice, right, I just need that value right there, and then I can quit, right? And I can output that final line there that does that type of damage. Okay. So let's come back over here with that in mind, and I'm simply just going to go into a while loop here. While what would it be? Let's call the first line here. So that's going to be forgets into the buffer at most 1000, and here we're reading from type file. Right, there we go. Right. I'm going to break out of this loop or actually I'm going to quit probably when I find that line that I'm looking for, right? But you could let's do it a little bit better. Char line is equal to that, while the line is not equal to null. Right, there we go. Then I will process the next line down here. Line is equal to forgets buffer 1000 type file. Right? But check to see if the line starts with line start. If so, you're done. All you need to do is print out that message there. Right? If so, print out the final message. If nothing ever gets printed out, we'll know about it. Okay? So check to see if that line starts with line start. So if line starts with line start, then print out that message. And I'm just going to copy and paste this here. All right. Printf. Replace this with the actual name eventually. Replace this with their type. Replace this with their name, their type. And let's replace this with a %f. Only out to 2 decimal places. And we'll end the line. And once we've found that, we'll discuss how, well, no, we've got this. Attacking name, attacking type. I already wrote it up there, right? Defending name and defending type. And then I'll go ahead and put into a double value here. Multiplier is equal to -1. We're going to want to set that, okay? And we're going to have to come back to that. Multiplier. There we go. All right, first of all, let's take care of this line. How can I tell whether or not a string starts with another string? Could I do this? strcmp? Well, here, could I do this first of all? No, that's a memory address check. Is strcmp between those two? Yeah, if that's equal to 0, what does that say though? They're equal. And is any line in there going to end up being fire, ice? Now it's going to have this trailing space and these, it's going to have this trailing number here and then an end line character. I only want to know if it starts with line start. NCMP, there we go. Right? And I only want to compare how much How many bytes? As many bytes as there are in that line start that I created. So strlen of line start. Now, if that's 0, then that means that the first part of that string is equal, right? And now all I need to do is find the other value there, right? And so it's going to be a to f of something here. Here's a nice quick and dirty way of doing it, since you wanted to do it the quick and dirty way, right? What I can do is I can say, well, this line, I don't care about the first x or n bytes of it. So what I could do is I could say the line that starts at that index, right? But that is a single character, okay? So how can I change a single character into a string so that a to f can convert it to a floating point number? Remember that this is, so let's walk through this. Line start is a char star. Line start, or sorry, line. All right. Line of, say, n is a char. We want it to be a char star. So what do I need to do to line n to make it into a char star? How do I take a regular old variable and make it into a pointer variable? Ampersand. Right? So if I put an ampersand in front of this, that will basically jump to this character, and then it'll treat the rest of it as a string, and I can call a to f to convert it to a floating point number. Right? So that's the quick and dirty way of doing it. Right? Okay, let's see if it works. GCC, not the Deadpool, but Flareon. There we go. Hey, 1/2. It worked. Right? So let's try another one. Give me your Abra. You said it was in the beginning. Give me your favorite Pokemon now. Okay, Mr. Mime. That was an issue in this morning section, and it was a period and a space, and it caused us some issues. So I remember that now. So the way that you can do this in the command line, by the way, is to put it into double quotes, and it'll just treat all that as one argument. It's is that correct? He's psychic. Okay. Anybody? Yeah. It is? Okay. And is it half damage there? Yeah. Psychic to psychic is half damage? Okay. Give me another one that you'd want to test. How about the other way? Flareon to Jinx. Fire attacks ice and does twice damage. Right? That didn't make sense in this morning's class, because I thought, well, if ice attacks it, then it melts into water, and water puts out fire, right? No. It died in the process. All right, fine. Do Pokemon actually die? It's a kid show. They can't die. All right. One more? Or is that enough? That's enough for me then. All right. Any questions on that? Again, the not so quick and dirty way to do it would have been to come up with something like this, or come up actually with a full matrix that looks something like this and then fill it in. The problem is that the matrix would have index values, and so what you'd have to have is this other array over here that had the names, normal, fire, water, etc., corresponding to the index values of these things over here. So there are lots of ways that you could have done it, but you asked for the quick and dirty way of doing it, and there it is. Again, if we give it bad information like Deadpool or Ryan Reynolds, there we go, then we're going to get seg faults, because we don't have any error handling code here at all. Okay? All right, good luck on your final, and good luck on the rest of your finals too, and have a good break.